Hello, welcome. It's Pactober. It's our second day of our schedule, and I'm Yousaf Nabi. I'm a community shepherd at Pact and a developer advocate at Pactflow. So we're just looking at the Pact.io Pactober website, where you can see all the activities happening. Welcome. It's Pactober. It's our second day of our schedule. Fantastic. Sorry about that. I was just watching the stream on another window and I need to mute that. So we can check out the full schedule. And in the full schedule today, we'll be hosting a Pact workshop. It says CI/CD, but actually we'll be looking at CI/CD techniques in another workshop just due to time constraints. So if you do drop onto the website, you can click on the link and you'll get access to the webinar link where we are today. You'll see the notes for the course and the background material. But if you just happen to go to our docs.pact.io website, you'll note that we've got a university section. And in that university section, there is an introduction to Pact, which is the hands-on lab that we'll be running today. And I'm pleased to announce that previously, before we would work within a GitHub repo, and the README steps would all be contained within there. We've lifted them out onto the website now as well, so we'll be able to use that. We'll be using this website on our left-hand side, and we'll still be downloading the code on the right-hand side. Hopefully, this should make it a bit easier to present and render for yourselves when you're working alone on your machine, or potentially if you're presenting this workshop with colleagues. The full workshop is MIT licensed. We fully and wholly recommend that people share, modify, and ideally share back the changes for others. So without further ado, we'll crack on. So the workshops, this workshop will be aimed at demonstrating core features and benefits of contract testing. Oh, sorry, I'll just pop the link for this course in our YouTube chat and the Zoom chat as well. Thank you if you are tuning in. So whilst contract testing can retrospectively be applied to systems, by following the consumer-driven contract approach in this particular workshop, so we'll be looking at when a new consumer and provider are spun up in parallel, and there can be uncertainty around what's to be built. We'll look at the challenges of some of the traditional challenges that would occur, and then how consumer-driven contract testing can apply with Pact to provide solutions to those problems. So our workshop will consist of 12 steps. So we'll be creating a consumer before our provider exists. Once we've decided what we're going to build, we'll then proceed through a series of steps whereby we'll iteratively introduce different components, and we'll be able to see how services will evolve over time. So we'll be kind of taking a bit of a time lapse, maybe over 3 to 6 months of development potentially. So there's a number of learning objectives that will be gained from following this workshop. They're summated in this table, but you don't have to worry about reading this table particularly now, or we won't go through each one of these steps in this table, because each of one of these learning outcomes is shown in each of the steps. So when we move on to them, we'll iterate more on these. But these are just here provided in a single view, so that you can provide course material when you're running a workshop. So the general requirements of this workshop, if you get to step 12, where we'll be introducing a Pact broker, you'll need to use Docker and Docker Compose in order to spin up a Pact broker locally. You could alleviate that potentially by using a Pactflow broker, which we'll introduce in a later step. But ideally, most of our users have Docker on their machine. And then the workshop has actually been provided in a variety of different flavors. So Pact, if you're unaware, is built in a core framework. So it was originally built in Ruby and then has been ported to Rust. And the functionalities within those core libraries are used in wrapper implementations in a number of other different programming languages. That makes every Pact concept available to you, no matter what language you are using, which is incredibly valuable in a microservice landscape with potentially multiple teams developing. The probably most mature of our workshops is the Pact.js one. So that's what the majority of steps will outline. You can run through any of the additional workshops. Your mileage may vary. We would wholly recommend, if you do get stuck, reach out to us in Slack, or if you do get stuck and manage to fix it, we appreciate contributions and fixes back to the workshop as well. So the first way you'll start with this workshop is by selecting which language you're going to choose. And then you'll clone your workshop. So we'll be taking the Pact.js workshop. And if you're unfamiliar with Git, I would just recommend looking at the GitHub website. They've got some great tutorials around how you can set up Git on your machine. And if you drop onto the GitHub website, there's some instructions provided on how you can download this website. There is an option to download it as a zip file. However, this won't be applicable to our workshop because we'll be stepping through different Git branches and the zip file won't have that information. So some of the different steps, there's different ways you can download the repo. You might be using SSH keys. You might just be downloading it via HTTPS, or you might be using the GitHub CLI. There's some convenience kind of commands here for you. So I have cloned one earlier. So I've got this repository on the master branch. And just as a note, as we move through each step is tied to a Git branch. So as you drop onto any one of these steps, you'll need to do Git checkout and then the name of the branch. And as a precursor, every single branch is self-contained and contains the dependencies for that particular project. So as you move into each branch, depending on the particular language, you'll need to run the appropriate install command to set up the dependencies. For the JavaScript project, it will be npm install. And if you're using one of the other workshops, just check the documentation within that repository, and that will tell you the correct command for that particular language. So you might be asking us, what is our workshop about today? So there'll be two components in scope of our workshop. So there'll be a product catalog website, and this will be we're just in a fictitious Acme company that sells products, and we will need a way to present these products to users. So this will be our product catalog website. And we need a place to store our the information about our product. So which products are there, the specific details about them, and also provide a mechanism for other services to gain that information. So that will be our product service. And in our scenario, we'll refer to it as a provider. Our product catalog website in our scenario will be our consumer. So this might be a common scenario in your organization where you've been tasked with developing some kind of functionality for your end users that needs to expose some kind of information about stuff within your business. And as we can see here, we've got two components, our website and our data store, and we need a way to interface between them. So this is where we'll use something called an API. and we'll actually use a HTTP transport mechanism. So something people are quite familiar with whenever we've visited these websites today, we've used HTTP to access them. So that's how that's the basic premise of our scenario. So in our workshop, we'll need to move to step 1. Once we've moved to step 1, we can perform an npm install. So what will be the learning objectives of this step? So now that we've decided on what we're going to build, there's almost a chicken and egg scenario. So we have to build a provider in order, we need a provider in order for our consumer to be able to operate in production. We need ideally, we need consumers to use our providing service. Otherwise, we don't know that our providing service will not necessarily be providing value to our customers yet, because they don't have the website. So we'll look at how we could potentially start designing our consumer before our provider exists. So we've got our this idea of this consumer, this website, and we said we need to communicate via HTTP. So we're going to make some web requests, and our consumer will implement a product service client that will call 2 methods, a get method on the endpoint product and a get method on the endpoint product, and that will be parameterized to take an ID. So there's 2 use cases here. Our users want to see all the products in our inventory, and once they have chosen a product, maybe from a list, they'd like to get individual details about that product. So our consumer will need to make a call to our provider in order to get this information. So the ultimate call that the provider will expose, or should expose, 2 endpoints, this product and product ID. Now our consumer doesn't necessarily call these endpoints directly. They use something called a collaborator. So here there would be a mechanism within the consumer that would be the smallest component of code that can call an external provider to get information. So the job of this API function here is to abstract from the consumer the detail that's contained within the provider. So anything in the consumer's application would just need to call API get product, and if the endpoints underneath change for the provider, that doesn't change for this consumer. They still call API get product. So let's take a look at this interface for our API get product. So we can see here we've got an API class, and our API class takes a constructor. So this constructor will be the URL of the providing service. And the idea of taking a constructor for a URL rather than hard coding the path to our provider is the ability to make our app testable. So we could inject a URL for our provider in production, or we could substitute that for a provider in a staging environment, or we could replace that for a provider that we've simulated. We've also got 2 methods here called get all products and get product. And these methods are what our consumer code will call in order to get information from this product service. Within this get product method, there'll be a HTTP client. So because we're using Java, the HTTP client we're using here is Axios. But if you're using a different programming language, you can use your favorite HTTP client here. So if we start this consumer, and we just need to wait a moment whilst the consumer loads. Sad times. So our products couldn't be found. And maybe if you're familiar with your console developer tools, we can see that we're unable to fetch product data. So why is this? Our application is set up to call a provider, but in our scenario, we have tried to build our consumer before our provider exists. Our provider isn't actually available at this moment in time, so we're unable to check that our application performs as expected in production, but because our provider is not available. But equally, we're not able to test that our provider exists. So it would be nice if we were able to test our application. So we'll move on to step 2. So as we move on to step 2, please don't forget to do the npm install or your appropriate install step. So we don't have our provider available at this moment in time, but we'd like to be able to confirm that our consumer application at least works as intended, or the API client that we've created that's going to call our provider will perform as expected. So we're going to use tests to perform that function. And if anyone's familiar with a testing pyramid that may have unit tests at the bottom, we're going to create a test at the kind of lowest layer, a unit test. So this test will be really quick to run and will give us really good feedback. So we've got our API.js here, which is our client code. So dependent on your client your particular programming language, there'll be different conventions for your tests. Unit tests or good unit tests will normally be written in the same language as your code that you are programming in, and the test will be located in the same code base. So in this API spec, we have we're going to import our API that we're going to test. And we're going to use a program to mock our provider. So why would we mock our provider? So we spoke before about our provider not being available. So in our unit tests, we want our unit tests to run very quickly, and we would like our unit tests to run without dependencies. So we would mock out our provider in order to simulate what the provider should behave like. And we'll be able to run our tests and hopefully get some feedback that our application will perform as we intend it to. So if you're unfamiliar with kind of test-driven development principles, we just need to remember the 3 A's. So we're going to arrange, act, and assert, and we have a system under test. So our system under test is going to be our API client, and we need to do the first of our 3 A's is our arrange. So we need to arrange our arrange our kind of system in a particular state in order to be able to test it. So we're going to use our mocking tool, and we're going to mock out a provider. And we're going to say that when our provider receives a request on this product's endpoint, it should return this particular response. And this particular response should be roughly this, it should be the shape of what we agreed kind of in that meeting when we decided what functionality we were going to develop for our system. And we have the second part of our 3As, which is our act. So in order to act, we need a system under test. So our system under test is going to be our API, and we're going to call a particular method on that. So we want our test to be scoped. So we're not going to test the whole of the API, we're just going to test a particular method. So here we're going to test our get all product. We're going to get the response of the get all product. And when we call the get all product, this mock is going to intercept our request to the get product. So as we call get all product is going to make a request to this product's endpoint. This data in this product object is going to be returned. And then we can use our regular unit test assertions, so the third of our 3As, to check that the response of the get all product is equal to a particular result. So here in this particular example, the response from our product API is the same as the response from our get all product method that is under test. Now, it may seem a little bit confusing that this particular test is testing the exact data that the product API is going to return. That isn't the job of this test, to test the provider. It's the job of this test to test get all products. It just happens to be the case that when we get the response from our provider, we return our response. Hello, Tian, I've just seen your comment. Nice to have you on board. When we get the response from this provider, we're just going to pass it straight through to our consumer code. There might be additional logic that you perform within your get product code. So you might marshal it into a products object. You might do some particular transforms on it. And if you are doing those particular transforms, it's the output of those transforms that you are looking to test in your unit test, and not directly the responses of the provider. So you're not looking to functionally test the provider. And we've got two particular tests here, one for our product's endpoint and one for our product ID endpoint. So we can run our tests with npm test, and then we have a -- prefix consumer. So this will just run the tests in our consumer folder. So we've got a just watch here. So if you see here that you need to no test found, you can just press A, which will run all the tests. So we can see here that our two tests have passed. So our get all product and get product ID. So from our developer's point of view, they've written tests that have covered the two functions as described in the API endpoint. So they feel that they're fairly confident with their test coverage that their application is going to perform as intended. So let's let's assume that whilst our developer was writing our unit tests, our provider has come along and provided their side of the provider implementation. So they've been busy working in parallel, but we've not necessarily been collaborating. This is the first time they've presented their code base to us. So if you're running this home, you'll need two terminals available. So one will be our provider terminal, a terminal for our provider, and we'll run npm start in our provider code base. So in this particular step, we've pre-prepared a provider code base, and that provider code base has a provider API, which will gloss over the details for the moment. We'll show you a bit more of them in the future. We'll just say that it's deployed somewhere, so they're giving you a URL for the provider. So what happens when we run our consumer? So we will assume that our consumer should run without issue, because we had our tests that tell our developer on the consumer side that everything's working okay, and our provider, we had that kind of agreement a couple of months ago where we decided what we would develop and how our APIs would behave. So let's start our consumer. And again, we'll just give our consumer a moment to start. Fantastic. So we can see that our website is now working. So if I'm going to open the developer console and we take a look at the networks tab, when we call this localhost 3000, our website, there's a call that takes place in the background. So here we can see a call has been made to 127, our local machine on the port 8080. And on the right-hand side, we can see our provider is running on the port 8080. So we made a request to get products. And if we take a look at a response, we had an array of products that came back. Brilliant. Our job's done. Hand it off to the testing team, and they're clicking around on the website, or we've got some automated tests in place, or we've passed it to our product owner, or potentially we've just decided to ship it straight to production. And you get your first call on the service desk. The website's not working, so you start clicking around on the website. So we didn't actually click on the see more button, did we? Oh no, sad times again. Our product 9 could not be found. And if we take a look at our website, our console again, we take a look at our network tab, we can see that we make a call to products 9 and we get 404 not found. So why could that be? So let's just take a quick look at our provider code base. So our provider code base is a simple Express app. So Express here is a API provider in the Java framework, JavaScript framework. If you're using a different language like Python, for example, you might be using Flask, or insert your favorite providing API framework here. So this server, when it starts up on port 8080, and it attaches a set of routes to this application. So if we take a look at our product routes, we can see that we've got 2 endpoints that are exposed. Let's just see if we can make this a little bit bigger. We've got 2 endpoints that are exposed, a product ID and a products ID. If we just take a little bit further dive into this provider, so these product routes are attached to controllers. So if we look at our controller for, say, get by ID, we can see that we've got a product controller. So this product controller will take our requests from anyone who is calling our provider, and they're going to route them into our provider code base. In our provider code base, we spoke earlier that our provider service needs to provide details of our products. So it needs to know what products exist. So in order to have a store of products, we need a way of accessing those products. You can think of a way of accessing those products as an API, and we'll use a product repository as a method to access the underlying data store that holds these products. So when we do a get all, we'll call our repository fetch all. And if we take a look at our repository, this particular repository uses an in-map memory representation of our product. So this is just for the sake of example. Probably when you build your service, you will have an external data store. It could be a Postgres database, it could be Aurora, it could be MySQL. You might be using an in-memory database, but in-memory databases are great, especially for the purposes of unit testing. So it might be worthwhile considering as you develop your product service on the provider side, making your application testable. So you might want to consider the ability to, say, for example, switch out your database provider. So for the purposes of testing at different layers of the stack, you could either replace your database with something other than production, say a copy of your production database. You could replace it with a fixed database for integration testing, or you could replace it with an in-memory database for unit testing. So these particular methods on this product repository will provide access to these products which are held in our in-memory database. So for the keen-eyed of you, you might notice our product router, which has the two endpoints, product and product ID. If we look at our consumer code base in our API is going to make two calls. So one is to the endpoint product and one is to the endpoint products plus the ID. So if we just pop them side by side, we can see that there's an inconsistency between these two applications. So that is potentially a bit of an expensive feedback loop. So let's move to step 3 and we'll see how Pact can come to the rescue. So you can feel free to stop these applications now, and we'll move to step 3. So unit tests are written in isolation of other services. When we write codes that talk to those other services, they're built on the trust that these contracts will be upheld. With our unit test that we wrote, there's very little way of checking that this unit test and the assumptions that we make about our provider will stay in sync with our provider code base. That's why our tests were green in our unit tests. However, when we actually implemented our code base, it failed to operate correctly. An integration contract test was coined by Martin Fowler and Ian Robinson, I think back in 2008, as a way of allowing your services to evolve gracefully. So Martin Fowler was quoted as saying, an integration contract test is a test at the boundary of an external service, verifying that it meets the contract expected by a consuming service. So if we'd introduced tests whereby we'd shared the expectations in our consumer code base with our provider, and our provider was able to assert these expectations prior to having deployed their code, we would have been able to ensure that these assumptions either stay in sync, or where these assumptions drift, we have a really strong conversation point. So how might one implement Pact in their application. So we'll just take if we're looking at step 3, apologies, I didn't follow my magic rule and do my npm install, so I'll just do that whilst we're talking. So we have our unit test, and in this step 3, we now have a Pact test that's been pre-prepared. So our Pact test will still follow our same pattern of our 3 A's, so our arrange, act, and assert. So in our unit test, we mocked out our provider in order to get fast feedback about our, in order to get repeatable, dependable tests without the reliance on our provider. In our Pact test, we'll replace this mock and we'll use Pact to provide our mocking capabilities. The side effect of using Pact in our unit tests will be a contract will be generated, and this contract will be able to be shared with our provider. So much like in our much like in our unit test, we will have to prepare a set of expectations of the state that our provider will be in for the purposes of this particular test. So we're not trying to set up our provider for every single scenario in this moment. We're trying to set it up for a very particular use case. So in our unit test on the left, it was a test to get all products. So on our right-hand side in Pact, we mentioned that Pact provides a mock provider. And our mock provider exists between a pair of applications. And Pact requires that we name these 2 applications explicitly. So you'll use your Pact framework, which you'll import, which will vary depending on the language you're using. But once you've imported it, you'll be asked to set up a Pact mock provider with the Pact DSL and a Pact constructor. The Pact constructor will take a few arguments. The required ones will be a consumer name and a provider name. We'll also need a host, which is where your provider will be running. So our provider will be running locally on our machine. We're taking place, or we're substituting for our real provider. And we have some additional options like logging options, which can be really valuable for checking the output of your Pact tests. Your Pact files will be stored in a particular location, and you can configure that with your particular Pact framework. And there's several different Pact specifications which give you access to different features and capabilities. Today, we'll be looking at the Pact specification v2 for the HTTP transport protocol. This HTTP capabilities are available in every single one of the Pact specifications. If you're looking for Pact message or Pact additional transport capabilities, you'll be looking for one of the later Pact versions. But don't worry, we'll be looking at those workshops later in the month. So depending on your Pact framework, the DSL will be somewhat similar. So we have the idea of a provider state. So we said get all products. So our state here is we have products that exist. We don't actually mind how many products we get as long as there are some products. And we're going to send a request that gets all products. So we have the idea of giving a request to get all products when there is a state of products existing. Our consumer is going to send a request, and that request they're going to send we mentioned before is going to be a HTTP GET request on the endpoint product. And then we'll set some expectations about how the provider should behave when we make that request. And these will be various different parameters, and they'll depend on your particular provider code. There's also the ability to use matches, which provide flexibility in the response shape that the provider can return. So a provider, if you provide an example to a consumer may have a pretty hard time trying to verify that exact same shape and all the same values that are in your payload. It might be unimportant to your provider to the main thing that's really important in our communication here is our schema. So we're interested in the shape of our message. So we're interested in the properties in this message existing, so ID, type, and name. And we want our type to adhere to a particular type. So we're using a pact concept called matches, and our pact matches will use a like matcher will take a name of the property that you wish to exist in your response, and it will take an example of the type of response that you wish to return. Based on this example, the Pact framework will infer the type, so this type will be a string, and when the provider looks to verify it, they will only have to return a shape that has the properties ID, type, and name, and they could return a different value other than credit card as long as it's a string. So let's run these tests and see what happens. So we can see here that our 2 tests passed. And if you take a look at the Pacts file in your consumer folder, you can see a Pact has been generated. So this is a JSON file that neatly describes the relationship between our consumer, the front-end website, and our provider, the product service. Within the interactions is all the information that was set up in our expectation in our test. So in our Pact test, when we performed our execution of our unit test, we called our system under test as we did before, and the Pact framework will assure that our consumer made this particular request. If the consumer failed to make the request that was set up in this expectation, Pact would throw an error and a Pact would not be generated. So this ensures that Pact will stay aligned with the actual request that your consumer code is actually making. That's really important because it ensures that the contract you're generating neatly summate the exact behavior that your consumer is actually performing. And because this is a unit test, we're getting this at the very earliest time. We're not getting this before we've spoken to the provider. So if our consumer issued that correct request that was set up by the developer, then the Pact provider will return the response that was set up. It's then the developer then has the ability to provide their unit testing expectations as before on the response that comes back from the get all products method that underlying within that method is called our mock provider prepared by Pact. So this will really enhance our testing strategy by giving us 2 feedback points. One, by ensuring that we are actually making the calls that we say we're going to make on our consumer side, and then we'll be able to provide these with our provider at a later date. So we're going to move on to step 4. And this is where we can pass on our contract to our provider. So we mentioned before that if we generated these Pact tests during our, if we'd written Pact tests during our consumer development, if we provide them with our, if we pass on that Pact file containing those expectations to our provider, and our provider can verify them, our provider will be able to get feedback that the expectations, that there was a mismatch between the expectations in the consumer code and that of the implementation. So what might a Pact test look like on the provider side? So it's a little less involved, one could say, from the provider side, from the consumer side, at least initially. So again, we'll use the Pact framework for your particular language, but rather than using a mock provider, we'll use a verifier. Here we have the verifier class from the Pact JS framework. And similar to our, we actually don't have any unit tests for our provider here. So our provider doesn't have any feedback other than this Pact test, or the, sorry, prior to writing this Pact test, the only feedback our provider has is deploying their code base and then a consumer telling them that their code base doesn't work. So our provider code base here will instantiate a Pact test. So the Pact test will be required to set up the, it's still going to follow the 3 A's. So we need to arrange our service. So we need our providing service. So we need to, and then we need to act. So we need to get our providing service to make it available in order to test. So in order to make our test quick, we want to be able to run our provider locally. And you, depending on your framework, it may vary on how you start your application. Here in this particular example, we're again calling Express and loading up our product routes. This means we are actually setting up our test framework. We're actually setting up an application to test it, but we're not necessarily testing our actual application. So our actual application that we'll be running is this server.js, and this also imports Express. So in an ideal world, we'll be importing this server.js or updating this server.js so we can instantiate it and start it as part of our test. We will update this workshop to reflect that fact. So once you have your Pact verifier, you will need to start up your provider service, whether you start it up on the command line or you start it up in your actual test. Again, will vary on your provider framework, but just needs to be available to you ideally locally, because you want to be able to control the state of that provider. And then you tell your provider where those Pact files live. So in an ideal world, we're going to share them in an automated fashion, but whilst you are building consumer-driven contract testing, it is a collaborative activity. So we would recommend sharing, your consumer shares that contract file with you in whatever mechanism. So here, our Pact file is on our hard drive. It's in the Pact file, the consumer folder of our Pact consumer, depending on if your consumer just provided it to you, it might be in your downloads folder and you could adjust your paths as appropriate. So let's run this provider test. So again, this provider test will run in a unit testing framework. So it started up here with our unit testing framework, Jest, which is a JavaScript testing framework. 10 minutes, we'll see how far we can get through. So we can see here that we've got a few bits of red, and that's okay. Let's take a look at these results. So we can see here that the get all products was okay, but our get product with ID 10 failed. And we can see that we're expecting a status code of 200, and we're expecting a content title application JSON, but we got a 404. You can look at a little bit of the extra detail that comes from the Pact core. And here we can see that we were comparing to an expected response, and we were expecting a 200, but we didn't get one. That matches up with our product routes. If we take a look at our product routes, we can see that we were the actual service has the endpoints product ID and products, and in our particular code, in our consumer code, we are expecting, we just go back to it, we are calling different endpoints. So these particular expectations of calling the products and products by ID endpoint have been surfaced in our Pact test. Fantastic. So this gives us the ability to have a stronger conversation with our consumer and provider. So if our consumer had shared this Pact file with our provider and our provider had written this Pact test, we would have been able to, the provider would have run that verification. They would have found out that this particular consumer is not compatible with them. And then they would have been able to have a conversation about how they move forward. In this particular instance, the consumer has been informed that actually the particular method of the endpoint format is correct in the provider code base. And as such, the consumer should update their code. So what will we need to do in our consumer code base? In our consumer source API, we would need to update our get product endpoint to now call the product by ID. Equally, we need to update our unit test. So we can see in our unit test, this has been updated. And we need to update our Pact test. Oh, sorry, that's our Pact test, but we also need to update it in our unit test as well. We could have update it in our Pact. Once we've updated it in our test code, in our production code, we then need to update it in our test code. If we didn't update it in our test code would throw the appropriate errors, telling us that we were expecting particular request on an endpoint, but we didn't receive it. So for example, in our Pact test, when we call our get product endpoint, we know that our get product endpoint is going to now call the product by ID. If we were to set up in our endpoint that our client was going to make the request product by ID, when we run the Pact test, Pact would tell us that a request was issued for product 10, but actually we were expecting products 10. We're going to make one for product. We can show that in an example. So we've updated our unit tests so we can run them separately, and they should pass. Fantastic, and we can run our Pact tests. And because we've changed our expectations in our Pact file, we will generate a new contract will be generated. We always ensure that we're calling a function here called rimraf, which is just going to delete the files that exist in our Pact folder. And that will ensure that every time we run these unit tests, we get an accurate representation and don't have any stale interactions left over. So we can see here that our Pact files have been, our Pact tests have passed, and we've got some new Pact files that have been generated. I mentioned before that if we update this expectation and we run this test, we should see that this test will fail, because we've set up an expectation that our consumer code will make the request product 10, but actually our consumer code is making the ID product 10. This particular error message has come in from Pact, so this is providing us really quick feedback if the assumptions in Pact don't actually match up with our client code. So again, really quick feedback. So let's just, and that won't have generated a Pact file. And we'll notice that, yeah, okay. Maybe that's not clearing out the Pact files as it's intended. Run our test again. So this will provide our updated test file. Once we've got our updated test file, we would share it back with our provider again. We'd say, hey, provider, we've updated our code base now. How does this look? Fantastic. So we know that if we run these applications now, they'll be compatible. So I'm not going to run the application now because I will try and move on to our next step. npm install. I've got that 3 minutes. In fact, what I will do is let's go back to step 5, check out step 5. So again, we'll just do an npm install in this step. So sorry, I've just had a look at the time. So we've got 3 minutes left. So where we are, where we're left at the end of step 5 is we've used Pact to help us get really rich feedback on our, we've used Pact in our unit tests on both our consumer and provider side in order to give us richer feedback in our tests rather than having to implement our code bases. Would recommend, if you wish to follow on in the rest of the tour of the Pact workshop, where you will see, we go back to our workshop outline, you'll be able to begin to add additional Pact tests. So we'll be adding Pact tests where a user does not exist. So we'll handle a different use case. Sorry, it shouldn't say missing user. It should say, I think it should say a missing product. But we'll handle the use case whereby we're calling the same endpoint, but rather than expecting a product to exist, we don't expect a product to exist. So we'll introduce the concept of provider states and how Pact helps with that. We'll then introduce authentication into our application, and we'll see how request filters will help us out with being able to augment our verifications on our provider side prior to verification. We'll also see how we can implement and automate the sharing of our contracts in order to utilize these changes in CI/CD. So the Pact Broker is an application that will allow us to share the contract and to store the results of those verifications. And if we just start our consumer in step 5, with any luck, we should see a fully compatible application. And then I will leave you with the rest of the workshop to work on in your own time. If you do get stuck with it for whatever reason, feel free to reach out on slack.pact.io. You can drop into the Pactober channel, where we'll be hanging around all month, or just in any of the language specific channels. So I did promise you a working application. So we've got our products front page here that was working before. If we click on a see more, we can see that we've got our product details returned from that endpoint. And just to show you that it's not all smoke and mirrors, if I stop our provider and run that again, not only could our individual products not be found, but none of our products could be found. So thank you very much for my whistle stop workshop tour. That's it. I look forward to seeing you in the next workshop, but our next wonderful thing you can look forward to is sorry, 1 second. The next thing you can look forward to on the 10th is the birthday bash. So it is something you cannot miss. We've got wonderful talks for you. So we've got an opener from JB Rainsberger. We've got an opener from Sam Newman. We've got a closing note from JB Rainsberger. You'll be able to hear from contract testing legends and microservice experts in our fireside chat, such as Dave Farley, Baz Dijkstra, and Lewis Prescott. And you'll be able to hear from members of the Pact core team and what the Pact maintainers have been up to over the last year, and how you can help them in the future. So thank you so much for attending. I really hope you've enjoyed this. If you're catching this up after the event, enjoy, but please, honestly, feel free, even though it might not be Pactober when you're watching this, feel free to drop into slack.pact.io at any point where you can come and chat along with other contract testing friends. Thank you so much for your time, and we'll speak soon.